During the Pliocene period, what is now the Po Valley was covered with the waters of the Adriatic, which stretched to the foothills of the Alps. The Gulf proved a favourable environment for cetaceans, toothed whales, and baleen or whalebone whales. In Piedmont and Emilia-Romagna, parts of skeletons of these marine mammals have been found in the sediment of the one-time Gulf of Whales. For a long period after its formation, the Mediterranean was a large gulf of the Atlantic with extensive coral reefs. But about 6 million years ago, the connection with the ocean was greatly reduced due to the collision between Spain and Africa and to the worldwide lowering of the sea levels following the formation of the Antarctic ice cap. These factors, together with intense and ongoing evaporation, have caused a serious hydrological deficit in the Mediterranean. The lowering of the sea level led to the emergence of vast continental areas bordered by little basins with a reduced circulation. Subsequent events laid down within them deposits of chalk, anhydrites, and potassium salts, which today constitute the Emilia-Romagna chalk and sulfur-bearing formation, which is the basis of the sulphurous water of Bacedasco. This salinity crisis is to blame for the almost complete disappearance of those marine species that existed in the Mediterranean basin and the consequent appearance of hyposaline organisms. About 700,000 years later, 5.3 million years ago, contact was resumed between the Atlantic and the Mediterranean, and with it normal marine conditions. This is well documented by the disappearance of the hyposaline species and the arrival of predominantly marine organisms. This is the point historically used to define the basis of the Pliocene. This is when the Po Basin starts its own story, as distinct from that of the Mediterranean, which over 4.5 million years came to a culmination with the rivers draining down from the Alps and the Apennines. The Plioccene's massive intervention was followed by a new tectonic phase, which led to the raising of the Apennine margins and the Po Valley floor, where there had accumulated millions upon millions of cubic meters of detritus brought down by the rivers. The marine deposits gave rise to a powerful sedimentary succession, characterized by one regressive cycle following a transgressive one in continuation, particularly noticeable in this part of the Piacenza area, in the Luganiano Formation and the formation of Castell'Arquato. The effects were sometimes amplified or diminished by the intense local tectonic movement which characterized the various parts of the Apennines. With the Pleistocene, about 1,800,000 years ago, the sea made its definitive retreat from the district of Castell'Arquato. This is well documented by an increased frequency of coastal deposits within successions of marine sediments, as in the case of the river Arda. The Plio-Pleistocene limit is very clearly marked in the entire Mediterranean basin by a net deterioration of the climate, which led to the disappearance of the last subtropical species, such as Strombus coronatus, and the appearance of Nordic guests, organisms typical of temperate or temperate cold climates, such as Arctica islandica. During the Pleistocene, the sea continued its eastward retreat, and the various tributaries of the Po formed their alluvial cones within the limits set by the mountain chains and the Great Plain. About 1,000,000 years ago, the sea disappeared from this area forever, and the vast areas which emerged in the newly formed Po Valley were populated by elephants, hippopotamuses, and rhinoceroses, whose ancestors had migrated from Africa across the natural bridges formed during the Messinian salinity crisis. In the Quaternary, the climatic deterioration begun in the Pliocene accelerated. Temperate or interglacial phases alternated with intense glacial phases, in which the permanent snow level crept down to lower levels. Interglacial periods saw the climate become milder and the average temperatures higher. These variations in climate were reflected by variations in the vegetation and fauna of the Po Valley. The warm temperate periods were characterized by the presence of fallow deer and a good number of elephants and hippopotamuses, while colder climates favored deer and chamois. The last ice age finished about 10,000 years ago and saw the presence of bison. At the end of the 18th century, fossil remains from the Pliocene Sea came to light in the clay and sandy soil in the eastern part of the Piacenza area, particularly in the steep gully walls and the cuts of the streams in the valleys of the Nure, Chiavenna, Arda, and Ongina. But 3 centuries earlier, Leonardo da Vinci, who was the first to recognize the organic origin of fossil remains, was able to see the shells collected in the Piacenza area when he was in Milan working on the equestrian statue of Francesco Sforza. He mentions them as nicchi, another word for shells, in the famous Codex Leicester. The first to realize the importance of these remains were some residents in the Arda Valley. They collected a large number of shells and bone fragments in the neighborhood of Lugagnano and Castell'Arquato, and these fossils formed the first collections. But the main contributor to research into the local Pliocene was Giuseppe Cortesi, councillor in the Tribunal of Piacenza and later honorary professor of geology at the University of Pavia. The importance and the great variety of fossils, especially in the field of malacology, attracted the attention of many scholars. Georges Cuvier, too, took an interest in fossils found in the Chiavenna and Arda valleys. It was the Swiss Karl Mayr who instituted in 1858 a geological plan which took its name from the province of Piacenza, Piacenziano, used to indicate the blue clays particularly typical of the Arda Valley. Recently, the scientific community have taken up again the concept of Piacenziano, redefining the time limits and above all proposing the reuse as a base reference of the stretch of stratotype from Monte Giorgio and Castell'Arquato. This area is unaffected by sedimentary gaps, and the evidence of fauna well document the extinctions caused by climate deterioration which accompanied the formation of the Arctic ice cap. The extraordinary abundance of fossil remains which characterize these sediments and their excellent state of conservation provide an essential jumping-off point for all those interested in the spread of fauna in the Mediterranean basin.